Okay, I'm just starting up the YouTube. Yeah. Welcome back. So in this part of the streaming series, I will continue um, on continue on the whole setup in terms of adding just some lines dynamically. Uh, uh, Maybe we want two versions of this. Maybe we want to add a line. Um, yeah, maybe we just want to. So the idea is that we would like to be able to create. Right now we have a lot of boxes. Um, we would like to be able to create these boxes from the mesh by parsing the vertex information at preload time. Um, since this is a so-called static mesh, it's not gonna change dynamically in any way. We can pre-calculate its bounding volume from the mesh and then the object transform. Um, So the idea is we will do the most basic and probably not most efficient collision checking algorithm um, as a starting point, meaning that we will do bounding boxes and check for collisions with other boxes. There are several ways to store a bounding box. Um, One of the most inefficient ways are by storing the minimum point in one corner of the box and the maximum point in one corner of the box. More efficient ways would be to store the center and then the either width of each dimension, or rather plane. Yeah, dimension is actually the correct word. Or the half width of the dimension. Since the last version lends itself to being able to check the volume the same way you would check a sphere, and sphere checking is pretty easy. efficient. Anyway, this means that we could create a specific method that just adds a bounding box debug. We could add a specific method that takes a point and creates a box around that with a certain scale, which is kind of like what we do with the lights. Or we could do something entirely different. Yeah, the problem is sort of deciding what information to pass in, since we will be doing the most basic bounding volume calculation, since it doesn't require us to change the way our objects are structured for now. We will do that, but maybe eventually we will change it. Yeah. I think that is the way we want to go, since we will be calculating the minimum and maximum corners of the bounding box. It would be fairly easy to pass that in as a parameter alongside a color. And maybe pass out an ID of sorts. For the debug information, so that we can reference that and change the color dynamically. Yeah, that's one way to do it. Would we be able to calculate the center actually, because then we can just take a point and then the scale along the different dimensions. Would we set the same? Yeah, maybe we could actually just mirror that if we just... It's somewhat backwards in terms of calculating the corners, then calculating the center. Well, maybe that's not too bad anyway. Maybe that's what you would do anyway, to calculate the center if you don't have it anyway. So whenever we would want to create a box, yeah, we could actually just expand on the current methods we have. make it so that we can do a color or just by specifying a point we want surrounded by a box. And since we can calculate the middle anyway from just taking the average of the minimum and the maximum, or rather just um, yeah. So yeah, the halfway point of these two vectors. So if they are from the origin, let's say we have a minimum over here. No, that's not correct. The minimum would be over here, and the maximum would be over here. If you first move to that and then add another, it would be out here. And perhaps the division would be right there. Yeah, we can test it out. Wait, passing in a point and some different information on how to scale the box. And since it structurally will overlap, we will do radiuses, half widths. Yeah. So now that's settled. So we want this to take in a position and then 3 times half widths and then a color, and then we would like something like a bool in terms of added padding for when the bounding box artificially needs to be a bit bigger than the or when they debug and the actual box. Since we wouldn't mind to be able to see the actual box drawn with a bit of padding so that we can actually see it and the meshes, the real mesh doesn't overlap too much. This is artificial. Yeah. So let's take a G-float 3 position. Isn't that what we use anyway in our build from point? Yeah, we do. And a const float pointer to free float half widths, and then a G-float for color, and then bool padded like that. Let's see. Is this allowed actually? Yeah. Okay. Let's do extra vertices here and extra indices. Since we will just set up the actual algorithm for adding a box right now, test that everything works. Let's do a position. Let's do a color. Let's see. Yeah, that's because, okay, it's supposed to be temporary in that version. And the indices. And then we want to create a render debug item, temp item. Let's do a let's see, we grab the last rendering item. We could do more elaborate parsing, but right now, when we don't have a function to remove anything, we could just do the last item. Yeah, this is not very robust, but it will get things working. We will pick the last one. Let's do a reference last item. So now we grab the last item, then we can set this to our index offset equals to the last item index offset plus last item amount of indices, and then the temp item vertex offset and we will add, since we know, let's see now. This is a somewhat hacky because right now we know that it's a box, which this also will be. Right now we're only doing boxes, so they will always have 24 indices and then 8 vertices. So yeah, we could do, yeah, we know it's 3 times the size. Therefore we do last item. Yeah, it's kind of hacky. and it's not very robust in terms of if we do more dynamic debug visuals, but for now it will work. Will not work if we stop adding boxes. Yeah. Maybe we want to store just inside this rendering item structure. So the vertex of it, maybe we want to store the amount of vertices just so that we can do calculations afterwards. This is only for ease of use. Let's do the same naming. So we do like that whenever we create it. We do store the amount of vertices. So now we can just calculate it by that. And we do temp item amount of vertices equals 8, and or rather just to do this somewhat dynamically, we do like that, and then amount of vertices is the box indices size, and we add that to our rendering items. But we of course need to add the actual information. So maybe we want some unsigned ints, vertex offset, which we pre-calculate here because we want to use it in other places. Index offset. Whoops, we got these swapped. Let's see. And let's just do them in this order. There we go. Now we know where inside our buffer to store our information. Which can be done by just mem copying some stuff here. Let's see, we need to adjust this. So we want to copy, but we want to offset by the vertex offset. Yeah, and we need to pass in convert this into a byte pointer. And we want to copy that, but we do not want the last part here. Same goes for this. So let's do index offset change this to a byte pointer. Let's see. Am I somewhat right that this will work? Let's just create a red box so we can know the difference. Yeah, let's test this. Inside our application, we will do some debugging stuff here. Has been run number 2. It's not used for anything. Oh, wait a minute. Wait a minute. Has been run. Okay, right now we don't use this for anything, right? No, so we can use F1 for that. So we only run this once. Our input polling is so fast that we end up doing add debug visual. Let's just do something that is maybe offset to the x-axis, up in the air, but not on that. And then we do 0, 0, 0. Can I initialize that this way? Doesn't seem like it. Too many initializer values. Let's just do a float. Temp 3, which is initialized as this. There we go. Pass in the temp. And we pass in just some garbage here because it doesn't. We would like to be for it to be red. So whenever we actually decide on that, we will do. There we go. Let's just add this. And lastly, we would like for it to be padded, but that's not implemented yet. All right, let's test this out. Let's see. So whenever we press F1, something is supposed to happen. And we get a crash. Something is definitely not happening the way it's supposed to be. Let's see. Is it like that we do the crash? It's not because of that. Let's see. Has been run number 2. I don't use the flag anywhere as far as I can see. So, yeah. What's the problem here? Let's see. If we disable this part of the code, does everything work fine? Yeah, no crashes. Let's see if we do like that. Well, that sort of crashes something. Why is that? Is it because I'm supposed to have some data here, but let's see how this ends up being calculated. So uh, oh, I see an error here. Is that what breaks the whole thing? Now it doesn't crash at least. Let's try to copy that. Nothing happens though. Nothing happens. So let's print this just to be sure. Everything done. Everything does get used there. Let's see. And we offset into the buffer. We do the copying. If we do not offset, we would change the first box, I think. Let's try that out. Yeah, that works. So we must be not be. Oh well, it's the starting point, of course. Oh my god. Yeah, that's why I'm ending up at the wrong place. Because, yeah, we do not want to calculate by that, but or rather offset by that, but we want to just get the starting point of where to write our data. Whoops. Now we got another error. What's the overflow? So maybe it's by how we calculate this. Maybe it's not. Yeah, so if we step into this, the last item, As an index offset of 72. Does it? We can't watch our window whenever we're stepping through debug mode. We have 24 vertices before the last item, and then another 32. Maybe I am supposed to. Yeah, because that's, yeah, it is correct. I think we're supposed to start writing to the buffer afterwards. Let's try disabling that. But it's supposed to get drawn here. And am I doing this? I know there's a problem somewhere. I mean, we would like to offset the memory pointer by whatever the last item contains. Maybe this is not big enough. I mean, I think we are building exactly what we're supposed to build. Let's see. So if we build this and we load it inside insights, we can check. Now I haven't pressed F1, so nothing is supposed to be written inside the last part of our buffer. Whoops. Let's see here. So the vertices here, let's do, we have the position, we have the color, for each vertices, vertex, and we do get some garbage value here. So yeah, 0, 0, 0, 0. I mean, let's do, can you do array of, or rather something like 2. Array. Yeah, of course I settled down on an awkward position with the camera. So data does get written here. 1, 2, 3, 4, 5, 6, 7, 8. But it is seemingly not really storing the information correctly. And the color is not correct either. So let's see. Let's step into this and the vertices, or rather indices, 24. The color is red. Let's see. It's 4 values. The position. Maybe I do. Let's try. Try that again. Exception thrown. Why is that? Because I just reduced. Oh, it doesn't mean anything. Do I end up invalidating that by moving something here? Why does it? Let's just check this out, because last item. So by moving that, we're actually moving the item data as well. So let's check. That's weird. I'm not sure. Maybe we want to set this as const. Does that help? Then we just move this, because it's supposed to just copy it, I think. Let's try that instead. So the last item here, no, it still gets invalidated. It doesn't change anything. Oh, well, no, now I know. It's because we change whatever this is pointing to. We actually reshape the vector. So this. So whenever we move, or rather reshape the vector, we actually end up changing all these underlying values. We could just perhaps move this. So this will make sure that the vector pointers are not gonna get invalidated. Let's see, copy value from vector reference. Because this kind of stores Let's see. If I cast it as an unsigned integer. This could be invalidated and give us all sorts of headaches, but I would like for it not to point to the actual object, but store a value that is not related to the it still crashes because I reshaped the vector. Value index. Maybe if I dereference this. Let's see. So I can't dereference. Let's see. This will work. So if I dereference the pointer, let's see. Let's test this out. I'm not sure it changes anything at all. But yeah, I want to store the value. No, it doesn't matter. Do I want to? It's because I end up. But how come this is bound up on? Let's do maybe. Does it help us to do referencing instead? Or will it still crash? Let's see. Let's see. I mean, yeah. So it doesn't want to copy. Let's see. Copy int from referenced struct. Let's see. Uh, 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 Let's see. Uh, uh, Hello, welcome. How are you doing? Uh, there we go. Yeah, maybe that's right. So instead of doing like that, we want to access the variable and copy it. There we go. Instead of that, let's try that. Does that help? And then we do the vertex offset. Let's see. Maybe this works. Yeah. Let's see. So we press the F1 key, and then we calculate our index offset. Let's see, index offset, vertex offset. And at least we do not crash now, because this probably stays the same. So yeah, let's see, even if we move it. Okay. Let's try that in NVIDIA Insight to see what we actually store in our buffer. our vertex buffer, arrange it by the data, and we offset it too far, it seems. What gets actually stored there? Yeah. Something is somewhat wrong here. It's definitely not supposed to do it like that. These do not get set, so we do not copy things correctly. And we also have some garbage values here, it seems. Uh, does it change after we update the vector? As before. 32, 69, 96 rather. Nice. Nope, it doesn't change. Somehow I'm offsetting too far into memory. Does this ever change? The temporary item. I mean, let's see. So the temporary item gets initialized and nope, that doesn't change. So whenever we create our buffers, let's see, if I just run the whole thing and check it out without pressing F1, I think our buffers should be clean in terms of the last parts of it. It does get initialized with garbage values. It seems, at least. Yeah, we do create some garbage value during buffer creation. Whoops. So whenever we, well, we're not supposed to copy the actual, it's just a, yeah, we're not supposed to do it on the mem copy. There's no reason to copy garbage memory over. So that's a first fix, at least. And then let's check out the buffers. Now they should be clean at least. Let's see, I check our buffers here. Yeah, so the last part here is empty. Let's just set it up as before and get some indices instead. So yeah, the first 32 indices are set up. It seems like the color is set up for even one more box. So 5 boxes. At least some color. But it doesn't have any positioning. Did we actually create a box at the origin? Anyway, so we are supposed to write to this part of the memory. It seems, at least, because that's empty. Did we not store one of the boxes correctly? Well, let's see, and the indices here. Let's do unsigned int. Now let's see. Okay, we can't do that. Int uint ushort uint 32. I think it's uint 32. Arrays of 24. Let's see. Index. Nothing gets written to the last 2. But we do have 4 boxes here. Let me just see. Did I? Let's see. So 8, 16, 22, 32. That's 4 boxes. 40. Oh, whoops. That's not the correct box buffer. Not the index buffer. Let's see. So 8, that's 1 box. 2, that's 3, 4 boxes, and then we have color information for 1 more box. Let's see. 1, 2, 3, 4. So why do we actually end up with extra color information? Oh yeah, because we create empty ones and they are pre-initialized. That is why. Let's see, so if this is 4, okay, do we end up creating something that is far too big? I mean, we have 4 here. So the box indices 120, and so that's 5, and that's fine. Yeah, so I think I know what's going on here. So we actually do create the memory layout there, and yeah, this is kind of unnecessary. since the vector already will get structured in a way that allows you to, or maybe we do want it like that. Let's see, not copying those, but instead of adding to that, because it's kind of obfuscated what we do whenever we do that, because we will rebuild lights like that, and then maybe now it will work. Let's see, because no, not yet, but I think we are getting closer. Let's see. Then inside our, whoops, our buffer stuff here, we'll check out. Does everything get laid out correctly? Yeah, now we only have the 4 boxes and the extra box space, which doesn't get pre-allocated any kind of way. It's just empty, which is great. Now we just need to copy something over to it. Now UN32, and we do 24. All right, and then only the last one is empty. That is great. So now at least our memory gets allocated correctly. Let's see. Let's see. So whenever we create this, maybe I do increase it too far. Let's try stripping out this part of the because then we just do the offset. I think this will make something bishop. Yeah, so it changes the last box now. So that's definitely not the way it's supposed to go. Definitely not the way it's supposed to go. So right now we change. We seem to be overwriting the old data. Let me just test it out by using the old method and see what happens in NVIDIA Insight to our buffer. Because maybe it's the rendering item that it gets calculated wrong. Maybe your data does get uploaded correctly to the buffer. I press F1 and we frame capture. Now everything should be uploaded. If something happens at all, let's see. Yeah, so now we fill out the buffer actually. We created an entirely red box. How about the indices? Let's do uint 32 and do 24. And yeah, we actually do get some information here. It generally looks like everything that we are used to seeing. Let's see. But it's still not enough to actually draw the item. So I think that we have a problem in terms of this actual structure here, because the data does get loaded. Maybe this is only supposed to be the offsets. Let's see themselves. Does that work? Why over offset something? Nope, that's not it. That's definitely not it. So we do create the data correctly. So if this is equal to 5, meaning that we added load test, we add a stop here, so right now it does nothing. Let's see. Doesn't it? Am I doing something completely wrong? I mean, let's test this out. Yeah, so first, this does rendering item size 4, size 5. All right. I mean, wouldn't you? Yeah. Okay. So let's step through it. The item amount of vertices, indices. Okay, we draw that one. Then we take the next one. We still draw the same amount. The offset is now 824. The offset is now 16. 48. This is the third one. The fourth one. Let's see. So suddenly the vertex offset jumps to 96. Yeah, these get flipped. That's why. Am I just unable to read what I actually amount of vertices? Am I doing this? Why do these get flipped? I mean, it seemed like it did get flipped. see. Nothing happens right now. Let's see. Did I disable the breakpoint? Perhaps I did. Yeah. So let's see our item here, A24, 2472. I mean, it would work perfectly the other way around. Actually, it's not correct. And up here, index offset. Ah, wow. I'm totally blind. It was staring me right in the face. No, that's awkward. There we go. Everything works as intended now. So now we can create a box dynamically. The next thing is that we would like to be able to use these parameters. So we will be creating some new utility functions which are almost going to be the same, except that let's see, build box from point, radius. So we will pass in a color, padded. Let's do some float padding here. So I don't think we want to scale anymore. We would rather like radius times 3. Let's see, so this is the one where the x is positive, meaning that the first radius will of course be x. This is the y, and this is the c. There we go. So this one is entirely positive. This one has a negative x. This one has a positive y and a positive c. Next we have a negative x, a positive y, and a positive, or rather negative c. Yeah, I'm just gonna copy these since the plus and minus signs already do all of the work, so we can just do like this. And then we do like this. And then we do like this. Oops. There we go. And we simply copy our color. Alright, I forgot to add the padding, which is going to be reinitialized as 0. So I actually have to redo this. Padding. Yeah. Yeah, we could do some find and replace. I'm just gonna do it manually anyway. I forgot that. Then do the padding as well here. And lastly, the padding here. Then we can just copy. There we go, and the last one with padding. Let's see. There we go. Let's test this out. We will comment this out, and instead of that, do call the method here utils, and we want the position. Did I not spell it correctly? Huh? Well, it's because I need to specify the assign. Then the color, then the half widths, and then the padding is fine for now. No padding. Half widths. Let's see. Const. There we go. Let's see, this is probably not gonna do anything because we have no widths right now. Let's try this. Yeah, we actually got somewhere. So the first is the width on the X. This is the, and then let's try that. Or rather the half radius. There we go. So the C is by far the largest component. The Y is that. And then we can do maybe, yeah, we could set up our buffer to take, let's just do a unsigned int extra boxes, which will be 2. We do times extra boxes. There we go. So now we create one, and then we can immediately create another one. That we will make green instead. And then we will add some logic here to ask padded. If it's padded, add perhaps a padding of 5. Whoops, a padding of 5. It's gonna be fairly large, otherwise do 0. There we go. Let's see. Of course, we need to tell it that it's not padded, this one. Let's see. There we go. So now you can see we create a padded bounding volume. That is awesome. Yeah. So that is probably a nice place to end this part of the YouTube video, since we got a fairly long way. Yeah, that is pretty great. So now we can do bounding volumes, we can do them a bit padded. The next thing is to actually construct some bounding values, calculate them, and set up for future collision detection. Yeah. Um, yeah. So that's great. I will be planning the next episode eventually. Probably will be doing some of it today. Yeah. If you found any of this helpful, feel free to comment, like, or subscribe, or follow on Twitch, or even support the channel. Um, hopefully I'll be seeing you around. Have a great one.